Well, hello there. I'm starting with this because I just think dandelions are so pretty. I know they're weeds, but I just think they're so pretty. So I wanted to start with that. Here I am in the backyard. Okay, so we'll just take a little walk so we can get to the lesson. I need to do some work on the back patio, but here's my flag. So that's that. Need to do a little work on that too. So here's again today. And here we go. So there's a few things. Oops. You can't see. There we go. That's working. Nope. There we go. Okay. Before the lesson, I just want to bring out a couple of things. And then actually I thought, ooh, we're going to make it 3. I thought there were 2 things, but let's make it 3. Okay. First of all, theta, Greek letter theta, is the variable we use for an angle. Just like we use x a lot in algebraic equations, we use theta for the variable angle measure. Okay? Now, when it talks about how an angle terminates, that means where the terminal side of the angle is. So the initial side, okay, the vertex is here. The initial side is always along the positive x-axis. So this is the initial side. Okay? Then where the angle terminates, if it terminates in the first quadrant, that means the terminal side is in the first quadrant. This is the terminal side. And we measure an angle like this. Okay, so here's your terminal side. Now, whenever you're making a right triangle, always draw the perpendicular to the x-axis to form a right triangle. So from the terminal side, if the angle terminates in the first quadrant, you're going to draw the perpendicular down to the x-axis to form a right triangle. So here's theta. If it terminates in the first quadrant, it's going to look like that. Okay? Let's just look at what all 4 would look like. If it terminates in the second quadrant, then you would have an angle this way, and you would drop your perpendicular down like that. So this is, if it terminates in the second quadrant, you have a triangle that looks like this. If it terminates in the third quadrant, then you would have a triangle that looks like this. If it terminates in the fourth quadrant, you would have a triangle that looks like this. So you're always going to make a triangle where the perpendicular comes to the x-axis. Okay, this is if it terminates in the first quadrant. This is if it terminates in the second quadrant. This is if it terminates in the third quadrant. And this is if it terminates in the fourth quadrant. Okay, so always draw the perpendicular to the x-axis to form a right triangle. And when I boxed this in, I thought, oh, that looks like a big old stretch limo. So let's just put some wheels on there. Okay. Anyway, so now let's get started with the lesson. What we're going to do is find trig ratio given another. And we're going to actually do all 4 quadrants. That's why I just pointed that out. We're going to look at all 4 quadrants. So here we go. Given that the tangent of theta is negative 84 over 13 and that angle theta terminates in quadrant 4, then what is the value of the sine? Okay, so here's what you're going to do. You're going to draw your xy axes. Theta terminates in quadrant 4. Here's quadrant 4. So here's where our angle terminates. We're going to draw the triangle to the x-axis. Here's theta, right there. Okay, now we know that the tangent of theta, they tell us, is negative 84 over 13. And we also know tangent, TOA, is opposite over adjacent. Okay, now here's theta. Now the opposite, notice that we're going down. If I were to name a point in this quadrant, this would be a negative. I would go positive, negative. So opposite is actually negative 84 right here. Think about if you were to name a point. This would be negative 84. The adjacent to theta right here is a positive 13. So that's where the negative comes into play. If I start at the origin and I go down to this point, I'm going positive, negative. Okay? Now, we have to use the Pythagorean theorem to get that side, to get the hypotenuse. So I'll call that C. So we have 13 squared plus negative 84 squared, and you could even make it positive 84 because when we square it, it's going to be positive, equals C squared. Okay, let's get out the calculator. And we know that 13 squared is 169, but let's just verify. 13 squared, 169, plus, I'm just going to type in 84 squared, 7056, and that equals C squared. So 7056 plus 169 is 7225. Now I'll take the square root of that number. Square root 7225. Okay, I get 85 for C. Now, you can just make that a positive 85. Okay, now let's figure out, always make the hypotenuse a positive. It's the legs that are going to switch up positive or negative depending upon the quadrant. Okay, now what do we have? So we've got this set up using the Pythagorean theorem. Use that to get that remaining side. In this case, it was the hypotenuse. Now go back to what you're asked for, sine of theta. So the sine of theta, remember SOHCAHTOA, is opposite over hypotenuse. So in this case, opposite over hypotenuse, the opposite is a negative 84, the hypotenuse is 85. So it's a negative 84 over 85, and that would be the sine of theta. So the difference here, when you did the other ones, they were all in quadrant 1, so you didn't have to worry about the sign, S-I-G-N, positive or negative. Now you have to worry about the sign, positive or negative, because here you're in the 4th quadrant. So that's what's different today. Okay, let's look at another one. Excuse me. Okay, given that the cosine of theta is negative 36 over 85 and theta terminates in quadrant 3. Okay, here we go. Theta terminates in quadrant 3. Here's quadrant 3. Make your right triangle like that. Here's theta. Theta is always the angle that's formed from the terminal side to the x-axis. Now, cosine of theta is negative 36 over 85. So the cosine, remember, is adjacent over hypotenuse. Remember, cosine, SOHCAHTOA, adjacent over hypotenuse. So here's theta. Now the adjacent, notice that we're going from the origin to the left. So that's a negative. So I know that my adjacent is negative 36, and then 85 is going to be my hypotenuse. Okay, now it's purely coincidence that the hypotenuse is 85 here and it was also 85 there. That's just purely coincidence. I just pulled this one up right off of Delta Math right there. Okay, let's go back here and complete the problem. Okay, so of course I have to use Pythagorean theorem here. So I'm just going to call this B because it's a leg. So we're going to do one leg squared plus the other leg squared equals the hypotenuse squared. So negative 36 squared, so 36 squared, 1296 plus B squared equals 85 squared, 7225. Now we're solving for B, so I'll subtract 1296. So B squared is 7225 minus 1296, and we get 5929. square root that, and b is, okay, let's take a look at this. Second square root, 5929, okay, 77. It's so cool, all these Pythagorean triples that come up. So b turns out to be 77. Now also that's a negative, because when I go from this point to this point, we go negative, negative. We're down here. Think about the coordinate plane. If you're in this quadrant, this might be the point like 2, 2. This would be the point negative 2, 2. This point down here in the third quadrant would be negative 2, negative 2. So they're both negative. And then this point over here would be 2, positive 2, negative 2. So keep that in mind. So when you're here in the third quadrant, both leg lengths are going to be negative. Okay, now let's see what we're asked to find. Okay, we have to find the tangent of theta. So the tangent of theta, remember tangent, SOHCAHTOA. Tangent is opposite over adjacent. So here's theta. Opposite is negative 77. Adjacent is negative 36. Now a negative divided by a negative is a positive. So that's a positive 77 over 36. Now let's see if that fraction reduces, and it doesn't. So our answer will be tangent theta equals 77 over 36. And that's going to be our answer. Okay, let's just verify. I'm going to go back to this delta math right here. And let's just scroll through that. Oh, let's see, where did there it is. Okay, so let's just scroll through that. And that's what it is. Tangent of theta is positive 77 over 36. That's the final answer right there. Okay, that's what you're going to do. In this particular section, we are doing, there we go. We are doing the 4 quadrants, but we're only doing the 3 major trig ratios, sine, cosine, and tangent. We are not working with secant, cosecant, and cotangent. So that's that. And I think 12 problems seems to be pretty good. So we'll just do 12 problems on delta math and have fun with these. Get out some markers, draw the triangles out, have your calculator handy, and just have some fun with these. I think they're pretty cool, kind of fun. Okay, that takes care of that. Bye-bye, everybody. Have a wonderful day. It's beautiful out. Enjoy the day. Okay, bye-bye.